Suppose we have a model that is created by standard Revit tools. All load-bearing elements should be marked as structural, and the analytical model should be generated in Revit. You can create a model with standard Revit families. In this case, the LIRA-SAPR program will recognize cross-sections at import process. But we also have family files that contain LIRA-SAPR sections for columns and beams, reinforced concrete, composite structures, and metal structures. These family files were created based on LIRA-SAPR assortments. You can load these families directly through the LIRA-SAPR plugin that is integrated in Revit interface. The LIRA-SAPR plugin allows you to add the parameters of SAPR analytical model to Revit analytical objects. We have added such parameters, and let's now select the analytical member to see these properties. The mentioned feature gives you a possibility to assign LIRA-SAPR properties inside Revit. For example, to generate perfectly rigid bodies at the intersections of columns with a slab. Through the first step, triangulation, you can specify the settings for finite element mesh generation, the division of bars, as well as the type and step of triangulation for plates. There are three available types of triangulation: triangular, adaptive quadrilateral, and quadrilateral. Triangulation settings can be assigned to the entire scheme, or you can assign an individual step of triangulation to several selected objects, for example, for these walls. The next one important thing is analytical materials. Revit does not contain materials for design analysis, only stiffness, but we can assign pre-configured LIRA-SAPR materials to objects for reinforcement analysis or analysis of masonry structures. There is a list of building codes for reinforcement analysis. Let's select the Euro code adapted for Kazakhstan. After that, you can get a list of available analytical materials. In addition, the connection between programs allows you to launch the Materials dialog box and add a new analytical material if necessary in SAPR system. There is a possibility to create a new material or duplicate and customize the old one. The new type of reinforcement for bars and plates, another class of concrete or class of reinforcement can be added according to any building code available in LIRA-SAPR. Then we need to refresh the list of materials and assign a new material to selected objects. The next step is export to SAPR model. LIRA-SAPR plugin allows you to perform export directly to LIRA-SAPR, or you can transfer model to SAPR, LIRA-SAPR preprocessor, and assign some additional parameters here. Plugin allows to transfer analytical model, and in addition to analytical model, we can transfer a 3D model through AFC file. Here in SAPR, we can specify various properties for the project, for example, building code for loads. In the dialog box Load Case Editor, you can specify the load case type and safety factors. The design combination of loads could be generated for existing load cases according to combination rules that are placed in a corresponding dialog box. And what about the data that we can transfer from Revit to LIRA-SAPR? At first, coordinates and topology of the elements in the analytical mode. Then the data that we already have seen, the load cases with loads. Plugin works with all load types available in Revit: point, line, and area load, and hosted point, line, and area load. Also, plugin allows to transfer different supports. For example, we can see now user-defined and hinge support for beam in Revit and corresponding support in SAPR. And all types of boundary conditions, fixed, pinned, roller and user-defined, can also be transferred. Analytical model can be supplemented with some properties that are available only in SAPR. For example, we can generate punching shear contours in slabs above the columns. Then we intersect the elements and generate finite element mesh. Triangulation settings are the same as we have already seen in Revit and are customized to our scheme. So we can just click on the button Triangulate. I should draw your attention to the fact that for these walls we have assigned individual triangulation step 0.3 meters in Revit. Then the scheme is analyzed in VISOR-SAPR module. The analysis results can be visualized in graphical form as contour plots of displacements, diagrams of forces in bars, stresses in plates, and so on. Analysis of reinforcement design are visualized in form of mosaic plots for upper and lower reinforcement along X and Y, and in form of a mosaic or diagram of reinforcement for bars. Results for bars can be visualized as percent of reinforcement or as a summary reinforcement in cross-section. The punching shear analysis was also performed, and we can see the necessary transversal reinforcement for zones in slabs above the columns. Then we create file with reinforcement results and import this file in Revit. The tab for results analysis is very similar to analysis in LIRA-SAPR, so this interface will be already familiar to you. Results for plates and bars can be visualized as mosaic plots and diagrams. The scale of the scheme can be changed, and it will influence on the size of color palette. The color palette can be customized to your needs in VISOR-SAPR. You can delete unnecessary intervals and leave only the 12th diameter with step 200 as the main reinforcement, and the 12th diameter with step 200 as the additional one. The colors for color palette can be changed as well. The customized color palette can be saved for further use. In Revit, you can load the customized color palettes for all directions of reinforcement and apply them to mosaic plot. Let's apply filter to our model and carry out the design of overlapping slab. Then create a reinforcement with the help of a rear reinforcement tool. Specify the diameter and step for reinforcement in all directions. Then create a rectangular zone above the support with additional upper reinforcement along X and Y. The mode taking allows to see whether the additional reinforcement is enough to cover the necessary intensity of reinforcement above the column. The necessary amount of reinforcement for punching shear zones can also be visualized in view of such dots.